All right, I'm Evan Weaver, founder, CEO of Fawna. FaunaDB is a distributed serverless NoSQL database, but it's a lot more than that. We're going to talk about why and how and what as we go through this talk. You can find me on Twitter and GitHub at Evan. So my story basically starts at Twitter, at least as far as serverless is concerned. I joined Twitter in 2008. I was employee number 15. And one of my biggest claims to fame is that, the first thing I did when I got there was fix the Apache timeout. Because originally there was no timeout. There was like one MySQL node on the back end, and it was often slow. Because this was, it was a Rails stack. Rails is LAMP 1.5. A lot of people wanted to tweet. The MySQL database was not so enthused about that idea. So it would frequently time out the request, and the browser would just spin and show you a white page after 5 minutes. So I didn't think this really made a lot of sense. I was like, we should put a timeout, like maybe 60 seconds is good. And in order to put a timeout, you have to have something to show when the timeout occurs. So we looked, me and Britt Salvatel, one of the other engineers, looked in the public images folder in twitter.com. There's a robot, there was a whale. We're like, oh, like there's like not enough capacity. It's hard to hold up the heavy thing. The whale makes sense with the birds. So we deployed it. And about an hour later, the product manager, Jason Goldman, came by and was like, I've really been thinking about this. And I think the robot makes sense. And we were like, it's too late, dude. It's done. So I spent the rest of my career there fighting that whale. And essentially, our story at Twitter was one of continual system saturation. Like for most of the time I was there for 4 years. I became a director, grew the back-end team to 35 or 40 people, built all the distributed operational storage, as well as worked on runtime performance and MRI, the Ruby interpreter, as well as Hotspot. And the limit to growth at Twitter was throughput. So I spent the entire time making throughput go up and up. And we invested early in other scalable data stores, but fundamentally there wasn't anything off the shelf which could do what we wanted to do. Like we were one of the first users of Cassandra outside of Facebook. We hosted the first meetup. We fixed the build because it didn't compile, which Facebook had not really told people about. But we just couldn't get these systems to a state where they were reusable, general purpose, soft real-time, global multi-tenant data platforms, because that's what we needed, and we thought everyone else needed it too. So basically, that's Fawna. And Fawna is part of a evolutionary story in databases. Computing as a whole has gone through a series of increasing abstraction over the underlying hardware. If you remember the bad old days of the 80s, you're writing BASIC on a machine, like the physical machine is there. If you're running System Z in some enterprise place, which probably few people in this room were, but maybe you were, you have to care about every layer of the infrastructure stack. And as we went through this journey, those layers got abstracted away by, management, specialization, ultimately, going to virtualization of the machine itself, then into cloud, which also virtualized the network, and there are software-defined networking products you can use if you still own your own hardware. Then into platforms as a service with things like Heroku, which abstract even more away from the underlying infrastructure. Lambda is somewhere in this transitional state as well, containers. Having less operations to worry about is fundamentally what's going on here. But operational data, like transactional data, mission critical, business data, user data, is really hard to deal with, both from an operational perspective and from an implementation perspective, especially with the journey to cloud. So data got stuck. And we're in a world now where you can get everything serverless, everything zero operations, except for the database, which still is a provisioned service where you have to think about, ports, capacity, where the machine lives, what the replicas are, security limits around it. Totally different world than the Jamstack, modern stack, new era development lifecycle that we're all here to talk about today. So Fawna is fixing this problem. But we should define, as Guillermo mentioned, I'm legally obligated to define what serverless is. we should talk about what we actually need from the data tier to have a transparent serverless experience. Here's what we believe at Fawna. I mean, one of the most important things that Guillermo mentioned is you can't have connection overhead. You can't have maintenance of, networks, interactions, long-term state between these transient compute functions and the database itself. It's a pain, it blows out your latency profile, it's not scalable. So you have to have an API to the data tier, which doesn't require any kind of persistence and doesn't have instantiation overhead when you connect. At the same time, you shouldn't have any capacity planning or provisioning. I mean, it's in the name. Like, you shouldn't have to think about the machine metaphor for the database that you're accessing. Like, even things like Dynamo, which are presented as serverless right now, still make you think about minimum and maximum capacity. They pushed billing down to very granular levels, but it's still fundamentally, giving you a tinier machine rather than a new paradigm for interacting with the data tier. You also need low latency access from the edge. Like, your app is principally in the browser. All the business logic lives there. The middle tier has more or less been wiped out. So you don't want to have to traverse back to US East 1 for your Redis or something to get your Pokemon state or your user login or what have you. That destroys the end-to-end experience for the app, especially if there's more work being done in the edge application, in the browser, in the mobile client. That means more traversal back to where the database lives. So if it takes a long time to get back there for reads and writes, it's not going to work very well. You might as well go back to a LAMP model where the server-side work is all centralized. Related to edge, you don't want to have infrastructure lock-in. Like, it's not very useful to only have your data live in AWS if your app is ubiquitously deployed. You also don't want to make trade-offs to get that ubiquity. You don't want to have to think about, do I want low latency or do I want consistency? You don't have to think about that with any of the other components of the stack. There are things you can opt into, like cacheable state within the Lambda container or what have you. But it shouldn't be mandatory to think through these trade-offs to build a functioning application. And then fundamentally, at the end of the day, these should be operations-free systems. There shouldn't be any constant administration. There shouldn't be any mandatory overhead. You shouldn't have to think about upgrades, downgrades, replication, durability, high availability, any of the stuff that typically makes databases, especially operational databases, so hard to deal with. But if you're picking something off the shelf right now, you don't have a lot of options. Like, we've gone through this journey over essentially every decade, from the physical mainframe to client server to cloud databases. But the current state of the world is you have your stateless serverless stack, and then you connect to the previous generation for your managed service to get a physical database that lives in a physical site that has physical provisioning limits, that is a middle ground between the old world and the new world, but not really part of the new stack, not part of the new modern development experience. So what's Fawna's philosophy that makes it different? I mean, fundamentally, our goal is to move away from the physical machine and move into the data tier as an adjacent component to the compute and asset serving tiers. So our goal is to ship APIs, not ship infrastructure components into tiny machines. And that means we need to support multiple APIs on top of the core architecture of Fawna. Specifically, right now, we support our own document relational interface called FQL. We just launched GraphQL support natively, which I'll talk about in a couple minutes. We're working on SQL, Gremlin for Graph, and some other best-of-breed capabilities, which all rely on the shared infrastructure. The same way you can run multiple, programming languages for compute on the same Lambda or serverless or WASM infrastructure. You should be able to use different query languages and different APIs to talk to your underlying data. That means not only can you access the data from different APIs and get capabilities which aren't exposed by those APIs in a standard way if you need to, but you're not locked into them. Your data is truly orthogonal to the implementation of the database underneath, both for access and for provisioning. You also need to build the system for the edge, which means especially, so these systems are typically read biased. You need to optimize for low latency reads, ideally no coordination whatsoever. You need to optimize for low latency global writes because you don't know where your end users and your browsers, your mobile apps, your clients are coming in from. It needs to be secure because it's exposed to applications which are running in untrusted environments. You also need control for things other than operations, specifically cost and compliance reasons. So you need to be able to select ultimately where the data lives. And on the provisioning, operational side, it needs to be truly serverless, like we talked about. It has to be totally elastic, no hardware or cloud service lock-ins, no operations, no administration. The way Fawna does that, I think, is really unique in the database landscape. Fundamentally, Fawna is a series of tiers which are all unified into a single monolith that runs on the JVM across each node in the global cluster. And what we're effectively doing for the query interfaces is we're compiling them into an intermediate representation that executes in the Fawna query engine. And the goal of that query engine is to unify the most common access patterns so that we don't have to invest in separate planners, separate optimization strategies, or traverse a network boundary to expose these APIs. So if you think about something like a compiler, in particular LLVM or GCC, there's a bunch of syntax front ends. They compile into an intermediate representation. That intermediate representation is what actually executes on the physical hardware. And fundamentally, Fawna is doing the same thing. So it's not like some of the other, for example, graph systems you've probably experienced, which are talking over a service layer to some underlying key value store. That incurs a lot of performance penalties, a lot of quality of service management problems. In general, it's an operationally painful experience, whether it's hosted or not. And that also means, the fundamental fabric of this data tier has to be quality of service managed, just the same way something like AWS Lambda is quality of service managed as a piece of infrastructure. So you shouldn't have to worry about noisy neighbors. You shouldn't have to worry about provisioning limits. If capacity is physically available, you should be able to consume it. And Fawna has a unique strategy here with subquery scheduling that's effectively similar to cooperative multi-threading in Windows 95. So queries that are coming in have yield points at IOs, loop boundaries, that kind of thing. And they always yield back to the recursive fair scheduler. And this happens natively within the Fawna process. There's no containerization. There's no virtual machine boundaries. Capacity is instantly available without instantiation overhead to whatever queries are active on the node. And that lets us accomplish the same kind of thing we accomplished at Twitter with the API and the rate limiting for public consumers of the API and the developer ecosystem, where we can saturate the machines all the time and take advantage of that capacity, which translates to better hardware arbitrage for you as people who are using the database to store data that has spiky workload patterns, different degrees of priority relative to the latency experience to your customers, different quotas, that kind of thing. And fundamentally, these data patterns, they need to integrate with the rest of the world. And that partly comes through standard APIs. It also partly comes through the unique replication architecture of Fawna, which relies on two things, in particular Calvin as the transaction layer, which inverts your typical lock-based model, and on temporal data storage, which means you can always get access to the history of your data for syncing to second systems, recovering replicas, integrating with other things that need to know whether the data is correct, whatever that may be. Calvin in particular is a unique transaction architecture that was specifically designed for global scale out. If you think about, the different, like in the NoSQL days of like 5 to 10 years ago, the typical story was that distributed transactions were impossible. Well, that turned out not to be true, but it's taken a lot of work in industry to get to the point where we understand how to do distributed transactions on the WAN with unreliable hardware. And Fawna's taken a unique approach in this regard, in that we integrated a strategy and an algorithm called Calvin, which came out of Dr. Daniel Abadi's lab at Yale, who's one of our advisors. And what Calvin effectively does is invert the clock and the log. So you're all familiar with the write-ahead log in Postgres. And that becomes a much more difficult problem at scale if you're trying to, transact across multiple regions, multiple nodes on very unreliable hardware. And the way Calvin works is that transactions are submitted at the edge, and they're pushed to the distributed partition scalable log, which is backed by a bunch of raft rings, without knowing what the result of that transaction is. So the order is determined before the result, which is different than any other database. And that means you can actually durably persist data without any replicas actually being online if you so chose, which I don't particularly recommend, but it's possible. Because what that log is doing is then defining real-time order by the order the transactions appear in the log, instead of letting it emerge as a property of the locking on the replicas themselves. And that gives us tremendous flexibility for doing different consistency models, for pushing data to the edge, for guaranteeing the highest possible level of consistency, specifically strict serializability, or what Google calls external consistency, which takes all this burden of managing the distributed infrastructure and the distributed consensus problems, like Guillermo was talking about. You have to put synchronization into the client so they know when they read or when they write. Well, if you have architecture like this, you don't have to. If you query the API, it will do the right thing in the vast majority of cases, and you can specialize or detune, so to speak, if you need to. But it's not mandatory to build a global application deployed to the edge. So as we've continued on this journey, kind of bottoms up, building the architecture, then moving into the new APIs, one of the things we've just launched is the native GraphQL support. And this relies on Fawna's query engine to translate or compile GraphQL schemas transparently into the Fawna intermediate representation. So the way you work with this, and you can check it out now, you can sign up for free. You don't even have to apply a credit card or anything like that. You import your GraphQL schema. All the supporting indexing infrastructure for the queries you've declared is built behind the scenes. And then you can use the GraphQL playground to interact with your data. And the experience is kind of that magic data cloud in the sky. You don't have to care where it lives. You know that latency will always be low to the edge application. You know that the data is durable. You can even get to the history of that data if you need to, if you have to rewind something. And we've been working with Prisma both on the initial launch, but also tighter integration into Prisma 2, so that Fawna can become one of the options in the data landscape of both legacy databases, serverless databases, the new world, depending on the gap you have to bridge for your particular application and your product goals. This is what's currently supported in the GraphQL interface. And a lot of this, it relies on some of the unique capabilities of Fawna, like transactions and asynchronous index building, arbitrary traversals, stored procedures, which we call functions, because stored procedures aren't cool, but they're very popular. So you can do everything you would expect in a normal GraphQL schema and trust that the data tier will take care of it. Now what Fawna is not is a platform. So our goal is to be an underlying building block for the rest of the new stack ecosystem. If you look at something like Firebase or even Dynamo in AWS, you're typically constrained in terms of ease of use by the rest of that stack. That's not what Fawna is about. Our goal is to create a ubiquitous data tier that can be composed through all these other systems, whether that's Zeit, Prisma, Netlify, Lambda, Google Cloud Functions, anything that can deploy, anything that can run compute, including legacy architectures, modern architectures, what have you, can integrate through Fawna, because fundamentally Fawna is exposing APIs, not provisioned databases, which need maintenance, security, other things around them to become operable and usable. And that also lets us enable, because we're infrastructure independent, a native Fawna experience on the laptop, or hybrid cloud deployments for situations where serverless cloud or managed cloud doesn't work for you for compliance reasons. So it's a fundamentally self-contained data tier which exposes all this capability natively without the need to orchestrate anything else around it. And our goal, back to the original serverless dream, is to stop having to think about where the server, in particular the database server, is hosted. So I found this cyber DBA who is up late at night trying to operate something. With Fawna, you don't have to, and I think our unique strategy is the biggest reason why. So I encourage you to check out the service, give us feedback in particular on GraphQL. We're excited to knock out even more integrations for different APIs, different query languages, different parts of the new stack ecosystem. We're also hiring in particular for developer relations. So if you're excited about distributed systems, if you're excited about databases, if you're excited about the new stack, please talk to me. Thank you.